Diodes are used in many modern electronic devices. A diode allows current to flow in one direction, but not the other. Diodes are always connected in series with a resistor, called a limiting resistor, that increases the circuit resistance and protects the diode from large voltages or currents, which could damage it. A diode is made when a section of P-type material with positive holes as majority charge carriers is placed in contact with N-type material, where the majority charge carriers are negatively charged electrons. Where the two types meet is called the p-n junction. At this junction, some electrons from the N-type material diffuse across the junction into the P-type material and fill holes. At the same time, some holes from the P-type material diffuse into the N-type material and are filled with electrons. As the electrons move from the N-type into the P-type material, the arriving electrons negatively charge part of the P-type material. At the same time, part of the N-type material becomes positively charged as the electrons leave. The result is a region around the junction called the depletion layer, where there are very few mobile electrons or holes. It's as if the electrons have been playing musical chairs, and in the depletion layer, all the electron players have found shares. This is the circuit symbol for a diode. A diode is made from a piece of P-type material joined to a piece of N-type material. The wide end of the triangle is called the anode and is the P-type section of the diode. The other end is called the cathode and is the N-type section. If the P side is connected to the positive terminal of a battery and the N side to the negative terminal, something interesting happens. The positive holes are attracted to the negative terminal, and the negative electrons are attracted to the positive terminal. The depletion layer shrinks, and current flows through the diode. We say that the diode is forward biased. When the battery terminals are reversed, with the negative terminal connected to the P side of the diode, and positive terminal to the N side, almost no current flows. We say that the diode is reverse biased. This graph shows how the current flowing through a diode changes as the voltage across the diode changes. Here, when the battery is connected the other way so that a small reverse voltage is applied, only a minute current flows, called the leakage current. When a large reverse voltage is applied, a large current flows and the diode breaks down. In this region, although the voltage is now positive, the current is still very small. The diode is not really conducting. The point at which the diode starts to conduct is called the threshold voltage. For most silicon diodes, this is about 0.6 to 0.7 volts. The threshold voltage is the voltage needed to reduce the depletion layer enough so that current will flow. Once the threshold voltage is reached, the voltage drop across the diode stays the same, regardless of how much current flows through it. There are many different types of diodes, such as light-emitting diodes and photodiodes. LEDs, or light-emitting diodes, emit visible light. In all diodes, whenever a conduction electron combines with a hole in the P-type material, a packet or photon of electromagnetic energy is released. In silicon-based diodes, the energy is in the infrared range of the electromagnetic spectrum. Diodes made from certain different materials release photons in the visible light range of the spectrum. For example, LEDs based on gallium arsenide emit red light. Green LEDs are made from gallium phosphide. LEDs are used in traffic lights, bike lights, power indicator lights, digital clocks, and many other applications. Remote control units use infrared LEDs as transmitters. LEDs are light-emitting diodes used to produce light. Photodiodes work in the opposite way to LEDs in that they detect light. If a diode surface is exposed to light, the photons provide enough energy for electrons in the conduction band of the p-type material to move across the junction. Similarly, holes in the valence band of the n-type material move across the junction to the p side. This means that by shining light on a photodiode, you can produce an electric current. If the photodiode is not biased, that is, it is not connected to a power source, then a voltage builds up inside the diode, leading to a current flowing. This is the photovoltaic effect, which occurs in solar cells. Normally, a diode that is reverse biased does not allow a current to flow. But if a photodiode is exposed to light when it is reverse biased, a photocurrent will flow. This means that the diode is off until a light shines on it. When it switches on, photodiodes are used as receivers in remote control units, in CD and DVD readers, security systems, and many other applications. Transistors are semiconductor devices widely used as amplifiers and switches. A transistor is a sandwich in which the bread is one type of semiconductor material and the filling is the opposite type. The middle is called the base, sandwiched between the emitter and the collector. In an NPN transistor, the emitter and collector are N-type and the base is a P-type semiconductor. When the transistor is on, the emitter-base junction is forward biased and the base collector junction is reverse biased. Free electrons in the N-type emitter move away from the negatively charged emitter plate into the P-type base, where some recombine with holes, producing a small base current. Most electrons cross the base into the more positive collector, resulting in a much larger current between the emitter and collector. Positive holes travel from the base to the emitter. A small signal in the base emitter circuit causes a much larger, amplified signal to flow from emitter to collector. In this circuit, a small base current here produces a large, amplified current here. By far the most common type of transistor used today is the MOSFET, or metal oxide semiconductor field effect transistor. MOSFETs are core components in the integrated circuits that control our computers, cars, phones, and all other electronic devices. An N-channel MOSFET consists of a layer of P-type semiconductor with two regions of highly doped N-type material connected to terminals called the source and drain. A third metal terminal forms the base. The semiconductor layer is capped with a layer of oxide that insulates it from a central metal terminal known as the gate. When a voltage is applied so that the gate is positive, electrons in the p-type material are attracted towards the gate, forming an electron channel between the source and drain. A strong current flows and the transistor is on. If the gate becomes negative, electrons are repelled and the channel is cut off, preventing a current from flowing between the source and drain. The transistor is off. So changes in the gate voltage switch the transistor on or off. In modern electronics, MOSFETs are microscopic, with the distance between source and drain being no more than a few nanometers, or millionths of a millimeter.